Good day, students. In this clip, we're going to be going over three examples on how to solve rational equations. So let's go ahead and write down the instructions for the examples. Solve the following rational equations and check your results. Okay, check your results. All right. So number one, let's consider the problem x minus 2 over 5x equals 1 over 2 minus 1 over x. Okay, so first thing we want to do is we want to find the LCD, make all the denominators common, and then we'll go ahead and eliminate that. So in order to find the LCD, what we're going to do is we're going to factor all the denominators, okay? So we can see the factors that overlap. All right, so we'll have x minus 2 divided by 5 times x equals 1 over 2 minus 1 over x. Okay, these two are prime, so they can be broken down. We just expressed 5x as 5 times x. Okay, so we can see that this denominator has a 5, so that means these two denominators need 5s. Okay, so we're going to insert 5 top and bottom, multiply this by 5 in the denominator and numerator. And then this one also multiply by 5 in the denominator and numerator. Okay, now this has an x that has an x. This needs an x also. So in the middle term, we're going to multiply by x, top and bottom, so we don't change the problem. Okay, now let's see what we have. Um, this has a 5, a 2, and an x. This has 5 and x. So this needs a 2, and this needs a 2 also. So let's go ahead and address that. So I'm going to multiply this by 2, top and bottom. And then I'll multiply this by 2 also top. Since there's a binomial here, I need to put it in parentheses before I multiply by 2. Okay? Alright, now let's see what we have. We're going to have, in the numerator here, distribute the 2 to the x and the negative 2. So we have 2x minus 4 over, in the denominator, 2 times 5 is 10x, equals 5x over 10x. Okay? Minus, and then 5 times 1 times 2 is 10 over 10x. If you notice, all the denominators here are the same, and that's exactly what the LCD is. So in order to get rid of the denominators, which are now common, we're going to multiply everything by the denominator. Okay? All right. So the LCD is 10x, so multiply every single one by 10x. So multiply this by 10x, multiply this term by 10x, and then multiply this term by 10x. Okay? Now on the left side, these denominators divide out, and then this 10x divides out with the denominator here, and then this 10x divides out with the denominator here. Alright, so what we're left with is 2x minus 4 equals 5x minus 10. Alright, now to get x by itself, we're going to subtract 5x from both sides to move the 5x to the left, and so add 4 to both sides. Okay, so let's go ahead and do that. We'll subtract 5x and add 4. Okay, add 4, add 4. Alright, so let's see what happens. 2x minus 5x is negative 3x. These 4's add up to 0, equals this 5's x and the negative 5x add up to 0. Negative 10 plus 4 is negative 6. Alright, so we'll go ahead and divide both sides by negative 3 to get x isolated. So our final answer is x equals 2. Okay, now is our answer correct? We have to do a check. We have to plug in 2 into the original problem to see if we are right or wrong. Okay, all right, now let's go ahead and do a check. So I'll have a check. Show you that here. We're testing x equals 2. So let's test x equals 2. So we're going to have plug 2 into the original problem. We'll have 2 minus 2 over 5 times 2. Is it equal to 1 over 2 minus 1 over 2? Is the left side the same as the right side? So 2 minus 2 is 0. 5 times 2 is 10. Is 0 over 10 equal to 1 half minus 1 half is 0? 0 over 10 is 0. Is 0 equal to 0? Absolutely. So our answer is in fact correct. Okay? Alright, so there we have it. Now let's move on to question number 2. Question 2, we have um, to solve 3x minus 3 over 5x squared equals 1 over x squared plus 1 over x. Okay? Alright, so we need to find the LCD, make all the denominators common. So to do that, what we'll do first is break down all the denominators and add on factors that are missing. Okay? So we're going to have 3x minus 3. And then this 5x squared can be broken down into 5 times x equals, and then this one can be broken into 1 over x times x plus 1 over x. Okay? Now this has a 5, so these two do not have 5s in them, so I have to put it in. So times this by 5, top and bottom. And then this one put 5, top and bottom. And then this has 2 x's, this has 2 x's too, which is fine. But the second term on the right side has only one x, so we need to insert another x there. So x and x. Okay? Now let's see. All the denominators have exactly the same factors, so let's reassemble them. So in this case, we're going to have 3x minus 3 over 5x squared equals 5 over 5x squared plus 5x over 5x squared. Okay? Alright, now let's go ahead and eliminate the denominators since they're all common. To do that, we'll multiply by the LCD, which is 5x squared. So multiply this by 5x squared, multiply this by 5x squared, and then multiply this by 5x squared. Alright, so what happens here is the denominators will cancel out with what we just introduced. This divides out, this divides out. We can do this because we're doing exactly the same thing to both sides of the equation, so it cancels out. Alright, we're not changing the problem. So that leaves us with 3x minus 3 equals 5 plus 5x. Okay? Now let's move the x's to the left and the numbers to the right. So what we'll do is subtract 5x from both sides to move the x to the left. And then I'm going to do the opposite of positive 3. I'm going to have negative 3. I'm going to add 3 to both sides. Alright, so let's see what we get. So we have, draw a line here so that we can separate what we're adding. So this adds up to negative 2x. This adds up to 0. It cancels out. Equals 5 plus 3 is 8. Okay? Now go ahead and divide both sides by negative 2 to isolate the x. Divide by negative 2, divide by negative 2. So we're going to have x equals negative 4. And there goes your final answer. Alright? Okay, now what we're going to do is we're going to do a check to make sure that our answer is in fact correct. So we're going to plug that into the original problem. So let's do a check. Here we're going to test x equals negative 4. Okay, so let's plug it into the original problem. We're going to have 3 times negative 4 minus 3 over 5 times negative 4 squared. Question is it equal to 1 over x squared is negative 4 squared plus 1 over negative 4? Okay, that's the question. Alright, so let's simplify the numerator here. 3 times negative 4 is negative 12. Negative 12 minus 3 over, we use the order of operations in the denominator. We do exponent first before multiply. If we exponentiate negative 4, we'll have 16. So 5 times positive 16. Alright, because minus times minus is positive. equals 1 over negative 4 squared 16 minus 1 over 4. Okay. All right. Now, let's go ahead and simplify this. The top minus 12 minus 3 is negative 15 over 5 times 16 is 80. Now on the right side, we need to find the common denominator, right? So we'll times this by 4 top and bottom. Because the LCD of 16 and 4 is 16, so I need to times this by 4 so that we have the same common denominator, okay? So I have 1 over 16 minus 4 over 16. All right, let's simplify further. We'll have negative 15 over 80 equals, on this side, minus 1 minus 4 is negative 3 over 16. Now these two have a common factor of 5, so I can divide this by 5, top and bottom. So negative 15 divided by 5 is negative 3, and then 80 divided by 5 is 16. So is negative 3 over 16 is equal to negative 3 over 16. Absolutely. So we're confident that our answer is in fact correct. All right. So there you have it. All right. Let's move on to question number 3. So in question 3, we're going to solve 3 over n plus 1 over n squared plus 5n equals 1 over n plus 5. Okay. All right, so let's go ahead and do this. I need all the denominators to be identical. So to make it easy to find the LCD, to make them common, we need to factor all the denominators. These two are primes, so let's focus our attention on the middle denominator. Okay, so we want to factor n squared plus 5n. Okay, so this is a binomial, quadratic binomial, so let's break each component down, each term. This is n times n plus 5 times n. You notice that n is common in both terms. So what do? That means we factor out that n, okay? Since it's common, it's n times n plus 5. Alright, so I'm going to reinsert it here. We have 3. This can be factored, so we'll leave it like that. 1 over n squared plus 5n is n times n plus 5 equals 1 over n plus 5. Okay? Now we need to make all the denominators identical. This is missing an n plus 5, so what do here? We multiply by n plus 5, top and bottom, so we don't change this expression, this term. This has n and n plus 5, let's leave it alone. This needs an n, because this has an n here, and that has an n too. So we times this by n, top and bottom. Note, anytime you're multiplying a binomial by a term, you have to group it in a parenthesis, okay, so you can distribute accurately. Alright, let's simplify what we have since all the denominators are now identical, n and n plus 5. We'll distribute this 3 to the 5 and the n. So we're going to have 3n plus 15 divided by n times n plus 5. We don't need to FOIL out the denominators because we're going to be eliminating them in a minute, okay? So 1 over n plus 5 equals n over n times n plus 5. Using the commutative properties, since multiplication commutes, the order of the product doesn't matter, so I switch this around. We're going to have the same result, alright? Okay, so now we have the LCD, which is n and n plus 5 times n plus 5, so we're going to multiply every single term by that expression, okay? So multiply this term by n times n plus 5, multiply this by n times n plus 5, and then multiply this by n times n plus 5, okay? Alright, so let's see what happens. This cancels out to 1, this divides out to 1, and this also divides out to 1. So we're going to have our final result is going to be 3n plus 15 plus 1 equals n. Okay? Alright, so let's see. Let's simplify it some more. So we'll have 3n plus 16 equals n. Let's subtract 3n from both sides. Subtract 3n, subtract 3n. Using the reflexive probability of equality, I can switch this equation around. So I'll have negative 2n equals 16. Okay? So to finally isolate n, I'll divide both sides by negative 2. So we'll have n equals negative 8. Alright? So the question is this answer right or wrong? Well, what we're going to do is plug it into the original question and check to see if we end up with a true statement, okay? We're going to plug in negative 8 for n. Alright, so let's go ahead and do our check. So for our check, we're going to test n equals negative 8. Alright, so let's go ahead and do that. So we have the original problem in view. So we're going to have 3 over negative 8 plus 1 over negative 8 squared plus 5 times negative 8 equals 1 over negative 8 plus 5. Okay? Alright, let's go ahead and simplify that. We're going to have negative 3 over 8 plus 1 over negative 8 times negative 8 is 64, and minus 5 times, 5 times negative 8 is negative 40, equals 1 over negative 8 plus 5 is negative 3. Alright, so here we have negative 3 over 8 plus 1 over 24. Is it equal to 1 over negative 3? Okay, we need to put a question mark here because we don't know if this is true or false. Alright, so to resolve these two fractions on the left side, we need to find the LCD. The LCD of 8 and 24 is 24, so this needs to become 24. So what we do, multiply this by 3 top and bottom. So we have negative 3 times 3 is 9, so we have negative 9 over 24 plus 1 over 24. Is it equal to negative 1/3? That's a question. Negative 9 plus 1 is positive 8. So we have, negative 8. So negative 8 over 24. Is it equal to negative 1/3? So we divide this by 3 top and bottom. Divide this by 8 top and bottom. And then our final result is going to be negative 1 over 3. Is that equal to negative 1 over 3? Absolutely. So our answer checks out. Alright? So that's that. So thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking up here. Please post a comment to let me know what you think about this clip. More clips coming from mathdoorstep.com. Thanks again and have a wonderful day.